Howdy! This is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper. In this video, I would like to teach you how to create custom previews in your Grasshopper components. And what do I mean by custom previews? So for example, let's say we have the problem of a point somewhere in Rhino in 3D space, all right? And then we have a vector with whatever coordinates, let's say 10, 10, and 10, or whatever number, right? And then what we want to do is we want to visualize a vector that is sticking out from this point somewhere in the direction of that vector, all right? We know by default that Grasshopper is not going to give us a visualization of this vector because vectors are entities that have direction and magnitude, but they don't have a location in three-dimensional space. So that's why we have to artificially give them a fake location, if you will, so that we can visualize them somewhere in 3D space, okay? There are several ways to do that. So for example, let's say we wanted to kind of mimic that idea. So what we could do is we could just use this component, the component line from a starting point, a direction, and a longitude, all right? And if I turn this visualization on, you can see that I can kind of see this line going in the direction of the vector, all right? However, this has a couple problems. One of them is that it doesn't really look like an arrow, like a vector, right? So I don't really know if I couldn't see this point, I wouldn't really know whether if it's pointing that way or the other way. And the other thing is that we can see this line because this is Grasshopper default visualization of the particular geometry that this one component outputs. All right. Now, this may or may not be useful for us, but maybe if we are like a bit more advanced, we actually may want to do something closer to this other tool that Grasshopper gives us, which is vector display. You can see the vector display is this tiny component that doesn't have any output, but it takes one anchor point and the vector, and it gives us this kind of arrow looking sort of thing that we can turn on and off, right? And that is now basically pure preview, okay? So we're going to want to do something similar to this. So what I would like to do is I would like to write a C# script component that is going to take an anchor, is going to take a vector, and the anchor is going to be of the type, you can see it is flowing on my other screen. It's a type vector 3D and point 3D, and the vector is of the type vector 3D. All right, I'm going to plug these two in here, and then I'm going to double click, and you can see I have my anchor, my vector, whatever. And what I would like to do with this component is something similar to what the other component was doing. Just no geometry manipulation, no outputs. I'm actually going to remove this output, and we could also even remove out. I'm not going to do that because I like having the console, but we could remove out to just basically have nothing, all right? And what I would look to do now is use this code to just purely display on the screen some custom preview like that arrow, all right? How could I do this? Well, actually, thankfully, Grasshopper gives us custom methods and custom tools that we can override in order to bypass the standard preview that is by default rendered by Grasshopper to any geometry that is output by the component. And instead of that, we can draw our own geometries, if you will, for the purpose of previews. What does that look like? Okay, let me show you an example. First of all, the way we access those special methods to do custom rendering of custom previews, is by clicking on this icon that we have here, that is the preview overrides. When we do that, what we're basically adding to our code is a bunch of functions, so a property in this case, clipping box, or two functions, draw viewport meshes or draw viewport wires, all right, that override the native functions that are embedded in this component. And whatever code we write here will override the default code. So Draw viewport meshes is a function that we would use if we wanted to draw geometry that has a mesh representation. So a surface, a B-rep, etc. Something like that. All right. Since we're only going to draw an arrow, I'm actually not going to use this one here at all. I'm going to leave it here for the purpose of examples, but I'm not going to use it at all. The other one that I'm going to use is the draw viewport wires. Wires are not the wires that connect Grasshopper components, but wires are basically geometry that can be drawn as a thin line in Grasshopper, okay? Or in the Rhino viewport. So this is the one that I'm going to be using. And you can see that by default, this method takes this argument called the preview arguments. This argument is actually really useful because what it gives us access to the drawing methods that we need to throw geometry into the Rhino viewport. Okay, so if we actually go to args dot, we can see that we have a bunch of things that we can access. So for example, we can access the display, the documents, some materials, the viewport, etc. So what I'm going to do is on the display, I'm going to press dot, and you can see that now I do have a lot of methods. Can you see all this draw stuff? Draw 2D line, 3D text, annotation, arc, arrow, bitmap, box, circles, whatever. There's a lot of stuff that I can do. So let me, for example, let me just draw a cylinder, like a simple cylinder. Is there a sphere? Maybe we can make this a bit simple. Is there a sphere? Yes. Draw a sphere, and then let's see which parameters it needs. It needs a sphere, and it needs a color. So I'm going to create a new sphere that is going to be centered at 0, 0, 0, and the radius, wait. So a sphere that is going to be centered in a point is going to be centered in a point. So new point 3D. I'm just doing a random example, okay? And with a radius of 2 units, for example. And then going back to the original draw sphere function, you can see that it also needs a color. So for example, I'm going to do system, drawing, color, and I'm going to choose from the list. It's unfortunate that this thing is so low on the screen, but I'm going to choose, for example, coral. I like scuba diving a lot, and I like orange as a color. So if I'm going to run this code, and you can see that all of a sudden, artificially, this component is giving us a preview of this NURBS sphere that is centered on the center. And depending on which shading we will use, actually we're not getting a different shading. Oh, because we're drawing this on the wired preview. Sorry, I forgot about that, right? So we can use this sphere as a custom preview, all right? And if I turn this off, you can see that the preview is gone, all right? So what that means is that we can use that method to override and create our custom visualizations. So for example, let's say that we want to use this anchor and this vector to create an arrow that is sticking out from this point in this direction. All right. So what I'm going to do is I'm going to do args dot display, and then I'm going to draw an arrow. What is that here? Draw an arrow. All right. How does that work? Well, it has two overrides. One is takes a line and a color. The other one takes line, color, and the screen size and the relative size. So we're going to just use this one. However, we actually need a line object in order to draw this arrow. We don't need a vector, which is kind of weird, okay? But we need a line, all right? So where do we have a line that represents this anchor and this vector? Well, what we can do is we can create a line that we can give to the draw viewport wires to get rendered. So how are we going to do that? We're going to do that here. We're going to say, I'm going to create a line called arrow. That's not a great name, but whatever. And that line is going to be equal to a new line that goes from anchor. Do we have? Yes, anchor and in the direction of vector. All right. Okay, cool. So now we have a line that represents the arrow that we want to use. to draw. But the problem is that if you remember the rules of scoping, because we declare this variable here inside of the run script function, this variable is actually going to disappear and not going to be available here. So for example, if I say system drawing color coral, all right, and if I now try to render this, I get an error, and the error is going to be, this is why you never should remove your output panel. The name arrow doesn't exist in the current context. The variable was defined here, and therefore when we finish the execution of run script, this variable disappears. So how can we access the arrow value from the draw viewport wires function? Well, if you remember from our previous videos in this series, we discussed how when we were doing animations, etc., we discussed how in order to create persistent data that is accessible to all the functions and is part of the global scope of a run of a script component, what we need to do is we need to define variables outside of the function in this area here, which is the global scope, or if you will, is the base scope of the full class that a Grasshopper script component is. So what I can do is I'm going to define the variable here, and then here, every time the script executes, I'm going to update its value with whatever new things are coming in. If I do this, because this is now available in the global scope, this variable is available here. So if I run that, you can see that now I have this orange custom pre-visualization of the vector that I want to visualize. And then if I change things around, this is going to update as expected. And if I turn the visualization off, it turns on and off. The problem is that it now doesn't do the thing where it goes from green to red when I click the component, because since I'm overriding my own function, my own pre-visualization, it overrides all those goodies that come from Grasshopper. Okay, so some pros and cons. I believe there should be ways to actually detect when a component is clicked and change the color, but I don't know how to do that off the top of my head. Maybe that is homework for you, okay, or for some future video. But some other things that are interesting are, for example, the fact that we have the arrow, but there's also other stuff that we could use as pre-visualization. So for example, this component also gives me the length, but the length is kind of difficult to perceive from how could we render the length in this arrow? So something that we can do, for example, is with custom previews, we can actually display text on the screen. So something that I could do is I can say, for example, let me calculate the length of the vector by saying arrow, can you just give me the length of this object? All right. I'm going to move this a bit farther up so that it's easier to see, right? And then what I would like to do is I would like to display that number on the screen, okay? So for example, how can I do that? I can go to args.display, and then you can see that I have draw to the text. This looks promising, all right? So let's see what this needs. First of all, it needs the text. So I'm just going to throw in lang, and I'm going to just forcefully convert it to a string. Lost. I'm going to do length, then I'm going to do system.drawing.color, and I'm going to do black for this one. All right. And then what else am I going to do? It needs the coordinates on the screen as a point to D. What is that? Let me define this beforehand. So I'm going to define point to D, coordinates on the screen, location is going to be a new point to the object, which is going to be, for example, pixel, I don't know, 25 and 25. All right, so the top left corner. And then, so I'm going to use location, and then middle justified. What is that? Whether if it's center or not. So I'm just going to do false. So it's going to be justified to the left. let's see how this works. So I'm going to click on this, and then I do have an error. So cannot convert from double to string. Okay, so what I was doing before is actually what needs to happen. So this I'm going to convert here, and then I'm just going to add these other parameters here so that they're easier to read. Okay, so length to string, system, location, etc., etc. And now you can see that the rendering is the arrow, but it's also this tiny text here. Okay, so I have this and have this, and there's probably ways that I can customize the typeface, and I can customize the size, etc., etc. Right? Or for example, let's say that instead of the top left corner, I want the bottom left corner. All right. How could I do that? Well, what you could do is you could say, well, I'm just going to give this a really large number, like 500, right? So I'm going to try that. But that's kind of like halfway through. Okay, well, then I can do 800. But now it's like way too much. Okay, I can eyeball this to 700. All right. And then it's probably somewhere there. But as you probably can imagine, that is not a great method, because now if someone resizes the screen, the thing doesn't stay there, okay, in the rendering. So how can we do this more programmatically? Well, we can, if you remember from the previous videos, we can actually access information from the screen using the Rhino API. So for example, we can read the size of the screen. We can read it by saying, let me access the Rhino document property of this component. And then here, I'm going to access for the views, get the active view, the one that is currently being displayed. And from that, let's go to the bounds object, one that has the 2 dimensions. And then let's see what is the height of that active view. All right. And then whatever the number is, I'm going to subtract 25 from that. All right, let me open this up. And if I do that, you can see that the number is now nicely displayed there. And if I resize the screen, because this function gets called over and over, you can see that this value it's permanent here on this tiny corner right here, okay? And if I could even be a bit nicer and just say vector, and I could just say the text is going to be vector length, and then close curlies, etc., etc. And then now you can see that I have an even longer display, like a more verbose one. Okay, beautiful. Now you may wonder, Jose, but how the hell did you know that you could get the height from bounds, active views, whatever, blah, blah? Well, that, I mean, I wasn't born knowing all of this. This is by experience, a lot of Googling, a lot of Grasshopper forums, etc., checking the documentation and taking a look, just simply spending some time looking at, if you just type Rhino document, and then if you type views and active view, and then you just sit down and be like, okay, what do I have? A handle, a floating, the display pipeline, the document, what are all this stuff, the client rectangle, active viewport ID. So just sitting down sometimes and looking at what the autocomplete gives you and what that might mean is also very helpful sometimes, just tinkering, okay? If you don't know where to start, the documentation is a good resource. If you don't know how to do something, just Googling it and going to the Grasshopper developer forums is always a very good thing to do as well. All those things can help you a lot, all right? And I think this is where I wanted to leave it for this video. Whoa, one thing I forgot to mention in the video. So if you have tried what I just did, you may have noticed something that it's not working great. So let's say I zoom out a little bit, and then I really make the vector go out of, like make it like really large. We are getting into a problem. I don't know if you can notice here. You can see how the vector somehow kind of gets out of bounds or gets out of the renderable area that Rhino is computing for this vector. You can see that the arrow, because it's really far in the negative x direction, is actually not even being rendered. But that actually changed if I zoom out, you can see that as I zoom out, all of a sudden the arrow shows up. But if I zoom in, this arrow starts disappearing. Why is that happening? Well, there's a long history of computer graphics technology that we will need to unpack here to really understand this. But long story short, what Rhino does in the background when it renders geometry is that in order to make sure that it adapts the rendering area for the camera, the frustum, and all the perspective parameters correctly, and it doesn't waste resources, what Rhino is doing in the background is that it's taking into account all the geometry that needs to be rendered, is creating this virtual bounding box around all that geometry, and then it's making sure that the rendering viewport, the cameras, and all the elements that need to display graphics on the screen are perfectly fitting everything that's inside of that bounding box. All right. This is a fairly low level thing from a computer graphics perspective, if you will. We typically don't need to care about these things because all the graphics that we display in modeling engines are taken care of by the modeling engine. But because we are engaging in computer programming and writing our own stuff, etc., now we need to start caring about these things. So we're getting this problem where Rhino is not aware that there is a custom preview that is made by someone in Grasshopper with this custom object and arrow, and therefore Rhino is not adjusting the viewport to the geometry of this virtual arrow. So how can we fix that? Well, it's actually quite easy. If you remember when we double clicked and we created our virtual overrides for the preview, we got the draw viewport wires override, but we also got a few other methods. This one, the draw viewport meshes, is very similar to this one, but it's for drawing geometry that is not line-based, like arrows or curves, or it's not linear geometry, if you will. It's geometry that has a surface nature. So I don't know if you're aware from other videos, but NURBS geometry, for example, is a mathematical entity that cannot actually be represented faithfully with computer graphics, because computer graphics can only render triangles in 3D screens. So you need to convert under the hood any NURBS geometry into a mesh representation in order to render it to the screen. So anything that is surfaces and B-reps and that kind of stuff, you need to do your own conversion to a mesh before you can do custom preview of those objects in the viewport. I should have actually made an example of that, but I haven't. You're welcome to try that on your own or to check our sample files in the GitHub repo. But the other function that I wanted to point you to is the clipping box function. The clipping box function is a function that Grasshopper uses to retrieve a bounding box representing and containing all the geometry that should be rendered. You can see that by default it's an empty bounding box, but what we need to do here is we need to calculate a bounding box that contains the full arrow of geometry so that when that bounding box is passed to the Rhino renderer, the Rhino renderer adjusts the view to all the geometry that we are custom previewing. This is just as easy as saying, well, the arrow object, which is living in the global scope, literally the first property that pops up in the autocomplete is bounding box, because all geometry objects, all objects that inherit from the geometry class in Rhino Common, they have a bounding box property, all right? So surfaces, B-reps, points, whatever, you can get bounding boxes. There's methods to calculate bounding boxes in Rhino for all elements. So as soon as I finish this, you can see that the arrow all of a sudden goes all the way to where it's supposed to be. And now, no matter how big or small I draw my arrow, Rhino is not going to clip that arrow and keep it outside, because it knows that there's a bounding box object that contains all that geometry. All right. So long story short, remember whenever you do custom previews that you also need to tell Rhino what is the bounding area that contains all the geometry, so that Rhino can adjust rendering to properly not clip any of that geometry. All right. This is part of the optimization processes in computer graphics. All right. Sorry. That was something I forgot. I actually recorded. You can see my shorter beard. I recorded this after the fact because I forgot to make this in this video. All right. Let's go back to the main video. This method that I just showed is very, very specific to C# script components inside of Grasshopper. As soon as we move on to the next sections, where I will teach you actual development of Grasshopper plugins from scratch, these methods will vary a little bit, but you're welcome to keep checking out this series and then learn how to do this with raw from scratch Grasshopper plugins. Okay, it's very similar actually. You will see. Okay. Thank you very much. If you like this video, maybe consider hitting the thumbs up, subscribing to the channel, and in the meantime, I will see you in the next video on this series. Thanks a lot. Bye-bye.